Nice. All right, come closer, guys. Don't be shy. Don't be shy. Just trip over all this stuff. Chris Augie's not here, so he can't freak out about insurance claims. Oh, Christopher, yeah, I understand that. Okay, cool. Welcome everybody. Yeah, thanks for coming out. This is fun. I've been like working on this kind of hobby project. Thought you guys would get a kick out of it, so thought I should invite you over. Also, with COVID and with us tearing our house down and moving into a little apartment for the past year, we have not had any like guests over or anything like that. So I was like, seemed like it was high time to like invite some folks over and just hang out. But yeah, so we got like a bunch of friends and family here, which is awesome. Thanks for coming. The biggest contingent is definitely like ex-Pearl, right? That's why I'm wearing the Pearl, repping the Pearl shirt. Yeah, so Pearl, for those of you who didn't work at Pearl, Pearl was a startup that a bunch of us worked at for a few years. It was like all ex-Apple people, really, really great team of people working there. Also, Sean worked there too, so. But yeah, cool to see you guys all here. This feels like kind of a Pearl type of event. A lot of ex-Apple DNA. But yeah, I've been working on this for like, I don't know, 2+ years. But like, that's a little misleading because it's very much like I'll work on it for 2 or 3 weeks and then not touch it for like 2 to 3 months. You know, like it's a very like on and off type of side project. I say it takes a special mix of like laziness, procrastination, but also like stubbornness and persistence to like stick with a relatively simple project for like over 2 years and like eventually get it mostly done. But I knew that like building this house was like a once in a lifetime like chance to do something fun, do something creative, do something kind of techie. Yeah, it's just like probably something like this wouldn't happen again. So I felt like I should do something cool in this house. But yeah, first thing I wanted to say was I built this for me, not for you. And what I mean by that is that I feel like everybody here is like trained to think in terms of like mass market product, you know, like how is this going to work for your grandma, whatever. And like this is literally built like just for this house, like it's just for me, you know. I haven't designed it to be used beyond that at all. So just like I'm just like shaping the lens through which you judge this project, right? Like don't be thinking in terms of like, you know, scalability or anything. But I think it'll work well for me. I mean, I think it's been a fun project to work on. So hopefully it'll continue to be a fun project, you know, to like hack on at this house. But yeah, just wanted to start with that kind of caveat. So first I want to go over some of the goals of the project and then I'll go over some of like the implementation after that. But the main goal was to control everything with software. So basically I wanted as much as possible. And this is kind of like what we've working at Tesla. Jeremy's here, there we go. Working at Tesla, you know, it's like we've seen the benefits of having software control over like every little detail of the car. You can ship software updates that change the way the door locks behave or the trunk, or, you know, like all this weird stuff, right? And so that was kind of the goal, is like take that same approach to the house of like, how, you know, what types of things would you want to control, and then like try to make everything there under the control of software. That way, like by just software updates, basically, you can change the behavior of the house. That was my main goal. And then specifically, I didn't want to like depend on other people's software. I wanted it to be like all my software. So that was another goal, was like, I didn't want to like hook together existing APIs or, you know, depend on whatever the hardware vendors like allowed me to do with their stuff. I wanted to have like kind of the full stack control over the whole system. So that was another goal. Another goal was wireless, or no wireless. So that was definitely a primary goal. Was like I didn't want to have any wireless, you know, Wi-Fi, Bluetooth, like anything. I want to do everything wired. That's kind of based on past experience on a few different on a few different projects. The way I like to explain it is, if you are one of the fortunate people in the room who are pilots, there's actually only a couple of us in here, but if you're a pilot, you're probably familiar with what it's like to have a bunch of pilots talking to air traffic control, which is like you get onto a frequency and you wait a few seconds to make sure no one else is trying to talk. And then, actually, yeah, David, we got a few pilots in here. And then you like transmit and like nobody responds, and like all the other pilots hear that you transmitted, so they all kind of shut up for a while because they're expecting air traffic control to respond. and then eventually, like everybody kind of times out. They're like, air traffic control's not responding. Maybe they didn't hear this person. Who knows? So then they like transmit, and then two people transmit at once. They step on each other. It's just a mess, right? And then what I learned at Perl while looking at Wireshark traces of 802.11 was that like the folks who designed Wi-Fi just like took all of those nuances and like made that a protocol. Basically, they just that was like that's Wi-Fi. You know, like you see all these devices like stepping on each other, and like the router's like, okay, everybody shut up, this guy's talking. You know, like it's like a bunch of pilots trying to talk to air traffic control, and sometimes they can't tell like. They hear another guy transmit, but they can't tell, like maybe the hub didn't hear that person, you know, like, so should there be a response or not? It's like a mess. So I thought about if I'm gonna put hundreds of these things, which I am putting like hundreds of things in this house, like the idea of them all speaking Wi-Fi terrified me. So I was like, no wireless. That was my goal, no wireless. That's me. I'm in the Venn diagram of pilots and Wireshark struggles. Another principle was something that Elon repeats to us very frequently. Jeremy, I'm sure has heard this many times. His mantra is all input is error. So basically the system should just do what you want it to do without any input required, right? And any time that the user has to manually input anything, that's an error that should be corrected by the system, right? So we should try to minimize that error essentially. And so that was another goal, is like, okay, hopefully like, you know, you don't have to like manually turn on lights, things like that, right? Like the house should just kind of like ideally in most situations do what you would want it to do without you telling it to do what you want it to do. And so I'll talk about some sensors that I'm using later in the talk to like how to achieve that. But the first thing I want to go through was like, okay, if I'm going to control everything with software, what do I want to control? I started like listing off like what are the things I could control. And the obvious thing is lights. And I may be able to control lights now. Ooh, the dimming works. I'm like surprised. We'll dim that down. Yeah, so the obvious thing is lights, right? That's like the first thing that you might think of. And you know, it's like, you know, once you have automated lights, the first use case, or like the basic use case is like, I want to like hit a switch and have like all the lights in the house turn off when I go to bed, you know? So like stuff like that is kind of the goal. But like, for example, you could go further than that. Like, for example, have another button that like turns off lights in the kids' room when it's bedtime, right? When it's lights out. And then even have like that button like disable all their light switches so they can't turn the lights back on. Yeah, lock them in. So yeah, I want to do fun stuff like that with lights, but I didn't want to stop with the white lights. So we got Christopher, good job. So I want to put RGB strips everywhere as well. And so these are the ones, if you can't tell, where you can control like the color of each pixel in the strip. So you can do fun stuff like have lights, you know, follow people around the room, or like, you know, just fun animations like this. But another thing I wanted to do was, let's see if I can switch. Oh yeah. So like if somebody gets up in the middle of the night to use the restroom, you can do like a nice soft red glow instead of white lights that's gonna like kill their night vision. Or you could do like a more soothing, like a blue or just something like more of a nighttime light where you can illuminate like the hallway, but you're not gonna like, you know, everybody has an experience at night where you're like, oh, you know, those lights are like really harsh. Or you can do like maybe more useful stuff. Like if somebody, like you're away from home and there's a intruder detected, you could go like police mode, right? Where like, you're like on vacation and like somebody's in the house, like the whole house starts doing this, like everywhere, right? And like they just feel like they're on a crime scene and they get out of there, right? That's one idea. I remember when we were working on the garage, the electrician was like, we're just going to do white in the garage, right? Because I'd been doing color everywhere to the point where people were like, is this guy crazy, right? And Chris is like, yes, he is crazy. Chris is the architect of this house, by the way. So you can give him credit for the beautiful design. We are going to do a tour later, so. But yeah, so the electrician's like, we'll just do white. I'm like, oh yeah, garage, like just white, like we don't need it. And then I was like, wait a minute. Like you start thinking about, and I was like, you know those like tennis balls where like, you know, people like pull in and like they know when to stop because the tennis ball hits their windshield or whatever. I was like, we could totally do like a, you know, like some sort of like a parking sensor where it's like red, yellow, green, you know, where it's like you're driving in and like the lights change color, like when you should stop, almost like a car wash. So I was like, you know what, let's just wire for color in the garage too. So I think we have color like everywhere. Like I think even in the crawl space, we got like color RGB, like LEDs in there. And then, oh yeah, I forgot to. Yeah, so that's RGB. One other thing was we're gonna do like kind of the same type of stuff outdoors as we're doing indoors. So we'll have like white and color, like all under the same automation system for like outdoor landscape lighting as well as indoor. And then just for fun, we're gonna put in the kids areas, we had some extra wires run so we could also do like ultraviolet, like black lights. So like up in where the kids' rooms are, they could do all black light. I think Ninjak said they're destined to go through what was it? Pink Floyd phase. Yes, the Pink Floyd phase. They're gonna be like just all black light all the time, basically. So looking forward to that. And then finally, and this is kind of fun, you guys can check this out, but holiday lights. So we had built-in, we're having built-in, oh, oops, there we go. Built-in Christmas lights essentially installed on the outside of the house. And I don't know, it was Augie, somebody thought of a really cool way of installing them where like they're not gonna see them at all, like they're gonna be totally invisible until they turn on and then you'll see something like this, I guess. I'm sure the neighbors will love that. But yeah, so we'll have like permanent, and we can, obviously we can do like orange for Halloween, like, like different holidays, right? So yeah, that's lighting. Next up is door locks. So like going along with the all input is error, like we wanted to automatically, like when you leave the house, just lock everything up. When you come home, just unlock everything, right? So you don't have to worry about like fumbling with keys and stuff. But automated locks are also good for guest access, house cleaners, things like that. That button that I hit when I go to bed will lock all the doors, that'll be cool. Most door locks on the market, there's some like pretty high quality door locks on the market, but most of them are like deadbolts in the door and they have like batteries in the door you have to change and whatnot. And so I found, yeah, and we've had those, like at the Pearl office we had one of those, that was a pretty crappy one, let's be honest. But I found these guys, it's kind of hard to see, but I have one right here. It's basically a solenoid deadbolt. Oh yeah, you can.
It's like an industrial.
No, it's residential. So and that one is like smoked bronze, which is like the the finish that we're using on all of our door hardware, which is cool. But it's like a solenoid deadbolt. This part here, goes in the jamb. So that's the powered part, right? And then in the door, you just have like a socket basically. And this one should work. Oh yeah. It's locked. It's unlocked. So that's cool. So we can control those from whatever we want to. And we're using those on like 5 or 6 exterior doors around the house. Yeah, so locks, window shades. So this room, I think this room in our master bedroom, we're planning on doing motorized window shades. So you can kind of see up in these arched windows, there's like a cavity up there where the window shade will sit. And then these guys will be like in the soffit. But yeah, we'll have motorized window shades. And then, you can do the basic stuff like just control one or all of them, do it automatically based on temperature, if you want to like block out the sun. But also, you can do more advanced stuff like detect where somebody is sitting on the couch, look at the position of the sun, position of the window, the position of the TV, and like close whatever shades are necessary to eliminate glare off the TV for that person on the couch. Like if you want to go really advanced, why not? It's like go nuts. HVAC, so we do want to control, simple air conditioning. We have some ex-nesters in the house, right? So the goal is do better than Nest. I mean, so we can maybe do better than Nest because we have so many more inputs, right? Like we could have temperature sensors all over the house, and we hopefully will know, like, have a better idea of where people are and stuff.
You're doing mini splits?
Yeah, so we have like Mitsubishi mini splits, so we can kind of control each zone on a zone by zone basis. We have like, how many zones, Chris? 4 in this house and 1 out there. Is there 2 out there? Yeah. So yeah, we have lots of zones that we can like play with. Yeah, so HVAC, that's pretty straightforward. So gates, we have a few. We're gonna have a car gate over here and like 3 pedestrian gates. And I wanted those to be somehow automated as well. And so like, honestly, I personally hate gate latches, like those little metal ones that like, when the gate starts sagging, they don't work anymore. And then you have to have like the string that you pull like through the little hole, like I don't know why that's still like the standard, you know, like it was pretty crappy. So I searched far and wide, and I found a better gate system. My friend Mickey at Disneyland. So at Disneyland they use something like this. This is like the Amazon version of what they have at Disneyland, but it's basically like just a metal plate on the gate, on the swinging part, and then this is just an electromagnet on like the fixed part, you know. And so they have a lot of these gates that like they can just like, you know, magnet shut basically if they don't want people going through. I assume they have a similar, and probably looks just like this, their automation system for locking those gates, something like that. So yeah, I wanted to put something like that on all the gates, so I could lock them potentially or unlock them, have a button for delivery people to like open them. You know, if somebody tries to open the gate while we're away, we can like get notified or something. It just seemed like a cool way to control your gates. So planning on using those. And it's basically exactly like the door lock. It's just like on, off, you know, it's pretty simple. Garage doors, I mean, why not? You might as well have control of your garage doors. Irrigation, there's a lot of smart sprinkler systems out there. You know, you want to use like weather, moisture sensors, all that stuff. I have not seen one that like detects a child on the lawn in a swimsuit and automatically turns on the sprinklers, but that is my goal here, and I feel like they should all have that as like their number one feature. I don't know why they don't. I guess they don't have cameras, but we will. We're watching. We are watching you. We have cameras everywhere. Okay, so that's kind of like all of the outputs for version 1. Or maybe, I don't know if that'll be version 1, but that'll be, somewhere down the line I'll get to like missile defense systems, flamethrowers, tasers, things like that. Rob can help me with that. I feel like he's the weapons expert, so.
You should start with that.
Yeah, right, start that first. But yeah, those are kind of the ideas I had with version 1. And honestly, version 1 is like, to move in, we need to be able to turn the lights on, so. That was the only like hard requirement that I get done, like ASAP is, and look, it's working, Sophie. Look at it. We can move in. But yeah, that was the MVP, right? I love how I'm just leaving the Christmas lights on for the rest of this presentation. Let's do it. But a lot of that stuff that I mentioned is not fully ready yet, and that's fine. Like I would honestly love to do a lot of that after we move in. But we need to have working lights when we move in. That's a basic thing. The door locks, by the way, like we're gonna have normal like key locks as well, and we'll just leave those unlocked most of the time. And so like door locks are not required to work. Okay, so that's like outputs of the system. So then we should talk about like inputs. So now that we have everything's under the control of software and everything's like on the network, then it's awesome. We can just like Pete and I can write an iOS app that will just control everything and just everything over the mobile phone. No, I'm not gonna do that. So I personally hate the idea of like getting your phone out, launching an app to like dim the lights. And I don't even like the idea of like the touch screens on the walls, like iPads or whatever, because you have to like look at them, you know. And so yeah, I'm planning on using just like light switches. So that is actually exactly what I have here. You guys can come check it out after, but these are kind of fancy light switches by a company called Buster and Punch. They're like machine metal. They're pretty sweet. But so yeah, we're just using normal like light switches and knobs on the walls to control all of this stuff. Kicking it old school. Of course, like the Buster and Punch stuff, they have the face plates and the knobs and everything. They also provide the stuff on the back, like the dimming modules and the toggle switches and stuff. But I'm not using any of their stuff for that. Like I'm doing my own stuff on the back and just putting their knobs on it, basically. As you can see on the back of this thing here, like, yeah, that's not your normal Buster and Punch switches. Yeah, so that's the main control mechanism. On the outside, I have a few places for our like awesome Star Wars control panels, which we will need for sure. I know Chris loves these. They're part of the Spanish style architecture. So we're gonna put a bunch of those around, like especially with the R2-D2 like spinning thing, that's key. But yeah, I mean, I actually did put places for like keypads or whatever we want to do in the future, so we can have fun with that for like exterior, like how to get in the house, how to unlock the house. Yeah, there's a lot of opportunity for like creativity, like for stuff like that, which I think is cool. In terms of so that's like human inputs, which of course we're trying to reduce since all input is air. And so in terms of sensors, You know, we'll have motion sensors. I have, you see like up in the corner here, in that corner, I just have like random like Cat6 going to a hole in the ceiling. And so we can like put any kind of sensor modules there in the future. Motion sensors, cameras, of course, is the big one. And yeah, so you can kind of detect where everybody is in the room. But yeah, ambient light, temperature, all that stuff. Well, you know, I can put any kind of sensors around the house. I have those things like everywhere. So even outside too. Yeah, so that'll be good inputs. Okay, so that's kind of the overview of like what, you know, the goals and like how I was planning on tackling it. To get into some of the nitty gritty, I'll start by talking about the hardware side, which I have no idea what I'm doing on the hardware side. I don't think there's any double E's here today though, right? That's great. Oh, dang it. He's like a wolf in sheep's clothing software guy, but he's really a double E. Yeah, so, okay, Rob will judge me. But actually, Rob has helped me on this some, so, but you can't blame him. The blame is all mine. Yeah, so what I decided to do was basically very similar to like, I call it like a PoE Arduino, if you want to think of it in terms of that. But I have like a main logic board that doesn't look like this anymore. This is an old version. The new version is the same, it's just much smaller because it's meant to fit inside like a single gang wall switch box. This one's a little big. I mean, it's not that big, but you know, it's like that big. The new one's much smaller. You can see it up there. But the idea was to have like a base board that provides like kind of common functionality. Dude, like this is getting a little much. And then I would provide like more application specific stuff as like shields, like what Arduino does, right? Like you can kind of like slap more functionality onto it. So you can see here like these 2 rows of headers. You can like, you know, you can snap some more stuff onto there. I'll show examples of some stuff I've put. But the base board is this. It's kind of 3 main components. This thing I really, oh, nice. So this is just an Atmega 328 PB. So that's like the microcontroller. It's honestly like not the best bang for your buck, but it was just like I was using it for prototyping and I just stuck with it. It does like everything I need, you know, like SPI, I2C, and timers and all, you know, like kind of PWM. Like it has all the features that I need, so it's working. And so for now I'm sticking with it. So that's like the main microcontroller. That thing talks via SPI to this guy, which is, oh, this board is mostly not stuffed, by the way. Sorry about that. There's like almost no parts on this board, but there's a few. Like these are all just empty, as you can see. But yeah, so the main parts are here, which is what's important. This is a WIZnet W5500, which is like a networking stack on a chip, which is pretty cool. Like I've been really happy with this guy. And actually there was an Arduino Ethernet, I think they called it, that used the same chip. So I felt like that was gonna be pretty well supported and whatnot. But it basically is like Ethernet, PHY, and MAC, and it also is like IP, TCP, UDP, like all of that on chip, which is really nice. And it has like a pretty easy, really easy to use like SPI interface. Like I was able to get, you know, just like open socket, connect, send data. Like that was like all very simple to get up and running. You know, and that guy talks here to the RJ45. And then up here is like a little PoE controller. And so the way PoE works is there's kind of there's a few different ways to do it. One is passive PoE, which is like, PoE is power over Ethernet, by the way. So the idea is to get your power and your like data over the same cable. You okay, Max? And so passive PoE is where you like go into your Ethernet switch configuration and you say like, just put 48 volts on this thing. Like, trust me, it's gonna be okay, you know? And like, that's one way of doing it. But then there's like, if you plug something in that's not expecting that, it could be bad news, right? Because it's gonna have 48 volts on like some pairs inside that Cat6 cable. There's like standardized PoE, which I guess you call active, where there's like a little bit of a handshake where like the switch detects that this guy expects, you know, is a PoE device and expects the 48 volts. And then it like classifies like, you know, class 1, class 2, class 3, like how much power should I give it? And so this guy here kind of handles all of that for me and like negotiates with the switch to say that it's a legit PoE device. And then it also has built in like a DC-DC switching power regulator, a voltage regulator. And so I'm switching, on this board, I'm switching from 48 volts down to 12 volts because I thought it would be useful to have a 12 volt output. A lot of this stuff runs on 12 volt, like this lock, for example. On the smaller version of the board, I actually got rid of the 12 volt output and I'm just switching directly to 5 volt, which is what this guy uses. And then there's an LDO here to switch to 3.3 for this guy. So I do have a 5 volt and a 3.3 volt power rail on those headers for any shields that are going to go on there. That's like the MLB basically. It's kind of just 3 components: MCU, networking, PoE. Yeah, so then I have some shields that are meant to go on top of that for like different applications, right? Because controlling the lights, controlling the lock is different from, a light switch or, something like that. So like, even though the base functionality is there, like you're gonna want to use it kind of in different ways. So the first shield is this wall switch shield, which is the one that's being used right back here. And this guy has like room for 3, so I guess 3 of these. I'm using these like dual pole toggles, and so each of them takes like 3 pins. So I can have 3 of those guys connected here, up to 3, and then 3 rotary encoders. And so like this setup I have here is 2 and 2, but I could add 1 more of each onto this one board. But yeah, so these are rotary encoders. These are just like, push buttons. This is a super simple shield, but it just takes these pins and connects them to the microcontroller, so I can detect when the switches are thrown or whatever. So that's shield 1. I have the light control shield, which is the one that's over here on this device, controlling the lights. This one's a little more complex. It just has like big MOSFETs to turn the lights on and off, and then it has like gate drivers there. So basically, like the gate driver turns the MOSFET on, MOSFET turns the light on. And I also do dimming via these guys as well. So I use the PWM on the microcontroller to switch them on and off quickly, and that's how I dim these guys. Woo! Works pretty well. But yeah, you might notice over here there's like RJ45s and some other stuff, which looks a little weird. But I don't know if anybody's worked with RGB LED strips, but this is how they work. So it's basically they have power pins and they have a single wire for all the colors for like the data line, right? And each pixel is 24 bits, right? RGB. And you just shift those bits in. So I have 300 pixels, so it's 300 times 24. That's how many bits I have to shift in, essentially, to color the entire strip. And each bit looks like this, right? It's like if you want to send a 0 bit, it's like you're high for a little bit and then you're low for longer. If you want to send a 1 bit, you're high for longer and you're low for shorter. That's how you send zeros and ones. And then at the end, you stay low for 280 microseconds, and then it like latches in all at once. The entire strip like adopts the new colors, basically. And so, yeah, so this is like a single wire. Like these are pretty tight timings, right? Nanoseconds. We're talking nanoseconds here. And so I actually did a test with like a long wire, like trying to send this signal, 100 feet or something like that. And it's a 5 volt signal, and it was, it was not working, which is like expected. And so I found somebody, because there's a lot of interference, there's voltage drop over that long cable that, it's hard to send a signal like this that far. And so I found some guy on the internet who had used these little guys, which are like differential signal transceivers. So you basically hook up like a twisted pair, and you have like one wire coming in and 2 wires come out, and it like makes a differential signal on those 2 wires. And then I can hook that up to the RJ45 to like one of the twisted pairs in the Cat6, send that over to the light, and then on the other side do the opposite and have the 2 wires in and 1 wire comes out, and I get the signal. And I tested it on like a 900-foot Ethernet cable, and it worked. So I was like, ship it. So yeah, that's why. So this one is designed, and this board actually has kind of 2 MOSFETs on top and 2 on the bottom. So, and it has 2 inputs. So it's designed to take 2 inputs. Each input has 2 outputs in terms of like power, and then also 2 data lines. So I can control here like 2 white and 2 color strips, basically. It's designed to do 2 white and 2 color. And I have white and color together everywhere, so it just made sense to like have 2 white and 2 color. Sweet. Yeah, so then the other end of that guy is this. It's super simple. It's just an RJ45. Power comes in here. That's my little transceiver to like do the differential signaling. And then the strip plugs in right there on these like 4 pins. The strip I'm using has 4 pins, but the 2 middle ones are both data. It just takes 2 data inputs. The reason being, if one of the modules burns out, it'll like there's like a bypass, like the other line continues, so you don't lose the rest of the strip after the broken module. You lose that one pixel basically. Anyway, that's just a detail, but that's why there's 4. Okay, so that's the hardware side. So moving on to the software side. Yeah, this is getting long. Okay, cool. So the software side has kind of a like hub and spoke architecture. Is that working, Sophie? Did Sean restart it? Dude, I feel bad now that I like called you. I know. Oh, thanks, Sean. So on the software side, yeah, I wanted to have like a central hub that controlled everything. And oops. So that's represented by this like Leet gaming PC right here. And then I have, that thing talks to all of my little boards that can be like anywhere in the house, in the walls or, you know, in like server racks controlling light, you know, lights and stuff like that. And then, so I kind of have hub, device, and then I call these peripherals. So you have like, you can have any number of peripherals hooked up to one device. So that's kind of the overall architecture. So it would be like, you know, hit a switch, this guy sends a signal to the hub decides what to do, sends a signal to this guy, turns on the light. You know, it's kind of the idea. But to more detail, on the device side, I wanted it to be as dumb as possible. So like the device, I didn't want any logic or state on the device, if at all possible. A few reasons for that. It's just simpler, you know, less bugs. Also, just easier to, if all the logic and state is on the hub, it's easier to change the behavior without like updating the software on the device, you know. And then you know, if I want to add more features, hopefully I can just, as much as possible, just do that hub side and not have to update the device software. So, so the goal of the device software was just to be like a TCP interface to the microcontroller. So like the device doesn't even know about like lights or switches, like it doesn't even have those concepts. It's just like the hub tells it like, turn this pin on, turn this pin off. You know, it's like very low level. And so it's almost like you're writing like microcontroller code on the hub and it just like gets remotely executed on the device basically. Yeah, so minimal state and logic on the device. It's written in C++. Rob, you know, you sold me. Like I used to be a hater. Now I'm writing C++ every day. Jeremy too, we love it. But yeah, no, it was good. It's been a good fit for this product. Like I'm keeping that side simple, so it's been fine working in C++. The device side does have like a simple bootloader with recovery and OTA. So if it like, you know, if it crashes a few times in a row, it'll go automatically into like recovery state and it'll OTA from the hub. So that's kind of nice. And then, you know, I can also command it to go into recovery mode and OTA from the hub. I think that's it from the device side. Try to keep the device side pretty simple. The hub is slightly less dumb, I would say. So like basically all the logic. So the hub does know about lights and RGB LED strips and locks, and it knows about all these concepts. I have like APIs for each of those things. Because the idea is that's where you want to actually like interact with the software like you're interacting with your house, basically. So all the state is on the hub, and in fact, all the state is persisted to disk at all times. And so like if the power is interrupted, if the hub reboots, like all state is restored immediately. So all lights that were on will be on, all locks that were locked will be locked. Like all the state is like immediately sent out to the devices and restored, which is kind of cool. And I have like this kind of hot reloadable config file that says like, here's all the devices, here's all the peripherals hooked up to each of them. The devices don't even know what's hooked up to them, right? They don't persist any state. This device doesn't know that it has 2 encoders and 2 light switches hooked up to it. When it boots up, it just connects to the hub and says, hey, I'm here. And the hub says like, oh, hey, put this pin in output mode, put this pin in input mode, like very low level, right? So the hub knows what's hooked up to every device via this config file, and the devices are just ignorant to that. The hub is written in Erlang, which some of you pro guys know that I love Erlang. It was like a really good fit for this because like the hot reloadable code is nice. If I make changes to any of the logic, I don't have to reboot anything, restart anything. It just like you can just hot reload it on the fly, which is really cool. It's good for like just high availability systems in general, keeping a lot of concurrent TCP connections alive. Like Erlang's really good at that. A bunch of little state machines. So Erlang is like designed to be actor model, like a ton of state machines, and that's what I have here is like all over the house, just like little state machines basically. So it was a really good fit for that. I do heartbeat from the hub to the devices. Like I think it's configurable on the hub. Right now it's like every 500 milliseconds. And if a device doesn't respond within, I've been getting like really low latencies. So I've had it down to like 10 milliseconds. If a device doesn't respond within 10 milliseconds, the hub considers it dead and like reboots it. I can even like tell the PoE switch to like power cycle that port, you know, so like that device can just get restarted basically from the hub. But yeah, so pretty strict timeouts on the device side. On the hub side, I did separate, like I have these libraries for like, you know, light and door lock and all this stuff. And I have all of the networking and like the system where the devices connect and it manages all the devices. Like that's all kind of separated into, you know, like libraries and whatnot. And then I have a separate module that's like specific house logic. Like when this switch is hit, you know, what should I turn on and stuff like that. And so I know I said I designed it just for me and not thinking of ever using it in any other house, but like I did take the time to like separate that out so you could like swap out the house logic entirely, you know, that's independent. Like, and you know, it would be pretty easy to use it in some other house, honestly. That's it. So I'm gonna do Q&A and then we'll do a house tour. Does anybody have any questions?
What are you doing with high voltage stuff? Do you
You
have
mean,
high voltage lighting?
oh, we do have very little in this house. That's a good question, yeah. We have some here in the kitchen. We have a few. So yeah, I wanted to have none as Chris remembers. I was like, do we really need that to be? Even like on the outside, I was like, that could be a LED strip, right? That could be like a 12-volt LED bulb, right? We could do that. But yeah, so I tried to have none, and honestly, over time, I might even have less than what we have now. But for the line voltage stuff now, I'm not doing anything with it. But for day one, it's just going to be on a normal switch. And then for day two, I will have a shield that can control line voltage. Like that's totally doable. And I've looked into like how to dim line voltage, and like it's very different from what I'm doing with low voltage, but it's like should be totally doable on a shield as well. So I am planning on tackling that, but not for day one.
Is the sensor and light network a private network, or is it all one house network?
I haven't gotten that far yet, but yeah, I imagine it'll be like a VLAN. Like all these things will be like on a VLAN. Right now I'm using this cheap switch that I got off Amazon, but I have at my apartment like boxes of UniFi switches, like those 48 port switches that are like $1,000 each. So yeah, and I know those have like tons of options for like isolating networks, right? So I'm sure I will do that. Keep it separate.
What are you doing for the camera sensors?
Oh, the camera sensors, yeah. So I have the first candidate hardware for the camera sensors, and I've spent a little time bringing it up. I spent like a few days on it, didn't get it working. I ended up like ditching it because I'm like, we don't need this to move into the house. I need to prioritize of like what we do. But yeah, there's a thing called an ArduCam that's meant to work with Arduinos. It's this tiny little camera module, and I think it's SPI and I2C. So like I can put it on a shield and hook it up to my microcontroller for sure. I just haven't got it working yet. But yeah, I mean, these guys, I can do motion, camera, you know, whatever I want up there. And I definitely do plan on doing cameras. And then those cameras, they do video, but they can also do like low frame rate, like JPEG stream. And so I would probably just do like a 4 frame per second JPEGs or something like that. And then just send those back over the Ethernet to the hub. And then the hub can run detections or whatever you want to do. Yeah, run some detection. Yeah, I would just use like an off-the-shelf like people detection, you know, and it's pretty. I don't plan on doing anything custom there, but it would just tell me like, here's a person, you know. Jeremy's familiar with this stuff. I'll have Jeremy help me out. But yeah, I can tell, you know, persons in the room, dogs in the room. You can detect different classes of objects. You know, somebody who looks like this in all black with a black hat, probably robbing your house, or it could be your friend Zach. You know, it's like one of those things. No, like intruder detection. But yeah, then you can tell exactly where people are, which is cool. Like in the stairs, you'll see we have some fun lights there. And so like we can detect like as you walk up the stairs, we can have the lights like kind of like follow you up the stairs or something like that. So the cameras will definitely provide an extra level of fun, I would say.
So is device provisioning all MAC address based?
Yes. Yeah. So obviously I've only hand soldered. I have a bunch of these that I've hand soldered. You can come check them out if you want. But I haven't done anything at a larger scale. So I don't have like a provisioning script or a system set up yet, but I will. I'll just have like a list of MAC addresses and like plug it in. It'll get assigned a MAC address and everything's MAC address based. Yep. And the MAC address will go like into EEPROM on the MCU and it'll just live there.
But that's how you know that that's the living room light.
Yes, everything is MAC address based for sure. And when the device first connects to the hub, it sends its MAC address. Like, I'm sure the hub could figure that out, but I just had it send it over. I forgot to mention the protocol is just like JSON over TCP. It's very simple. So the device just sends like a JSON dictionary. It's like, here's my MAC address, and the hub reads that.
Have you plan to deal with your single point of failure?
What's the single point of failure?
Hub?
Oh yeah, so that's another good thing about Erlang, right? Is like Erlang is built to support like automatic failover, hardware failover, right? So I can have a hub here, I can have a hub out in the ADU, like a warm backup basically. And if this thing fails, that one will just seamlessly take over and like they'll be in sync and stuff. So yeah, for sure.
What if you lose city power?
Yeah, I mean if your power's out, your lights are going off, but yeah, but we will have power walls. I can show you guys where we're gonna put power walls. So we will have battery backup for the whole thing.
You gonna use like traditional low voltage outdoor lighting and just use your stuff as a controller, or are you gonna go crazy on that too?
Probably go crazy on that too. Let's be honest. I'll probably start with but yeah, the off-the-shelf stuff is just 12 volt, so like the same way that I'm controlling these guys, I could control the off-the-shelf stuff too.
How many thousand feet of Ethernet cable?
It's a lot. I don't know. I just know Nelvin's been sending large bills for. Yeah. So as you can see here, so this room is going to have beams that go down like this as well. And the LED channels will be integral into the beams. So the LED channels are like these aluminum channels that you can see them there in the kitchen in the ceiling. They're aluminum channels that you run these LED strips in. And so those will be integral into the top of the beam basically. And so you can see at where the beam meets the wall, so he ran like power to both, so it'll be like a U-shaped strip, right? So it'll go up across that beam and back down. And he ran power to both ends of the U, and he ran the blue is a Cat6, so he ran a data just to one end of each U. So this is the power for the next U, this is power and data for that U, this is power for if that makes sense. So we have lots of low voltage wiring and lots of Cat6 wiring all over that. And then every switch box, even the ones that Nathan referenced where they're line voltage, I ran Cat6 to those as well, so that in the future I could, yeah. So every switch box has Cat6 going into it. Some of them only have Cat6 going into it.
And your interaction is physical then. So it's like switches on, switches off, buttons on.
Yeah.
Voice control kind of stuff. Nothing on the phone app.
We could totally do that in the future, but I don't love voice control and I don't love app control. So they're like, maybe I'll decide to do that, maybe I won't, I don't know, but for now I'm not. But yeah, I mean, that's definitely an option. I could even integrate with HomeKit. Like Apple actually opened the protocol for HomeKit, like for non-commercial use, you can like read the protocol docs and like implement it. So I could even have like, hey Siri, whatever. Oh no, I probably just triggered some stuff. I could even do that and have it like integrate with my stuff. I feel like we need some Christmas police. No. Yeah, there we go. That's better. What else? I was going to mention something else about the MAC addresses that Rob was saying. Oh yeah, DHCP. That's what I was going to mention. So I have the MAC address is in EEPROM, so each device knows its MAC address. That the WizNet chip, which I love, it has like UDP, TCP, all the good stuff. It does not implement DHCP. So like to get an IP address for these guys, I had to write a DHCP implementation, which was just drudgery. Like I was not looking forward to that, but it works. So these guys, I think right now they're hard coded for this demo, but I do have a DHCP implementation, so they wake up and get an IP. But that's what I think. If you noticed on the OTA slide, I mentioned it was over it was over UDP. That's the reason, is because the DHCP implementation wouldn't fit into the bootloader. The bootloader is very small, and so I'm just using like UDP broadcast, no IP address for OTA, which is a little funky. But yeah, if you guys are interested, off into the weeds, there you go.
And it just, do you control like your power and everything from every point, or is there like where your circuit breaker or something, then you kind of pick up right with this offering?
Yeah, so we have like a few places around the house. One is in the laundry room. There's like a few hub areas basically. Laundry room, the master closet. There's like a few places where like a bunch of wiring goes into, and in there we will have. I didn't bring it because we're using it at our house, but we'll have like a pretty beefy LED power supply. It'll be like this one that I'm using here, but not this one. But here's like this is meanwhile a pretty beefy power supply. I'll have something like that, and then maybe like a shelf of those, right? Like a bunch of them, like in a rack, and then I'll have on that same shelf, I'll have my little controllers. So it'll go like power supply to my controller, and then from there it goes out to the light.
So that's where you pick it up after.
Exactly. Yep. Yeah, because even like these white lights are super bright. If we go like full brightness, it's pretty crazy. That's just one strip. We're gonna have 12 strips in this room, so like it's gonna be kind of a lot. So they pull a lot of power. So like we can only really do like safely 2 of those strips per power supply. You know, technically.
Is all the lighting done via the strips, or do you have like chandelier or light bulbs or regular lights?
I fought hard against that stuff, but we ended up getting a few anyway. Yeah, we have some of that, like decorative lighting, and like I said, I will try to even convert that to low voltage in the future. But for now, it's just line. Yeah, we have like some pendants in the kitchen. We have a chandelier in the entry, stuff like that. But not much, not much. We returned all the can lights, you know, literally. Like Augie bought a bunch of can lights. We're like, send those back. Yeah, Sophie opted out. She had no faith in the system, so her office is over in the corner. She has just can lights in the ceiling. Like, there's not a strip to be seen. But yeah.
On Sunday morning, her office will work when you're coding.
I'm like, sorry boys, do your homework in mommy's office.
Make your own.
Yeah. Yeah.
What about electrical outlets? Are you going to be
I didn't do.
this at all?
I didn't do any like relays in the outlets, which I kind of regret for like switchable outlets. Yeah, possibly could be added later, but it wouldn't be super easy. But yeah, we didn't have a lot of use cases for switchable outlets. This one, I do want to do something here because I actually have I have like what looks like Christmas lights, like the green string of lights, you know, but they're actually these individually addressable RGB LEDs. I have one of those that I would love to just plug in here for the Christmas tree, you know. So yeah, but yeah, we didn't do anything with the outlets yet.
On the white strips, can you change the color temperature?
This one, no, but yeah, they have those where you can. There's like 2 different, you know.
Warmer.
Yeah, warm or cool. Yeah. So.
Anything with your line voltage, you're going to want to use underwritten hardware.
Yeah, for sure. Yeah, I mean, Rob actually recommended. Remember back in the early days, you're like, this is a good relay. I've used this a lot. So yeah, I could use like put that next to an outlet, you know, or somehow in the wall next to an outlet.
What about electric panel? Are you doing like smart electric panel?
I am. Yeah, I mean that has nothing to do with this system, but yeah, I have 3 of them, 3 span panels here, so I'll show you guys those when we walk around. Yeah, and then I forgot to mention these channels here. We probably have some unused ones sitting around you can see, but they're cool. They have like these big flanges on the sides, and you like put them in a slot in a drywall, and then they like tape and mud over the flanges, and so like the mud comes right up to the edge of the. There we go. Yeah, see those crazy like flanges with holes.
Are you able to trim the strips to length?
Yeah, you can trim these guys. These ones you can trim between every single light. These ones is like every 10 LEDs or something like that. You can snip them. And then they have like push connectors. I even bought some 90-degree push connectors. I was thinking about using it for this demo to have like sharp corners, and I was like, not worth it. Gaffer tape. But yeah, you can get like different degree like push connectors. I don't know if you can get 120 degree, which is, if you guys, when we go out to my workshop, I have these like hexagon lights, which caused all kinds of grief with the people building this house. at every level. The drywall guys, the electrician, like everybody hated those things. I had to like push really hard and be like, I want the hexagons. Augie was like, let's just do something square or rectangular. I was like, no. But I think you'll agree when you see them, they look cool. And they're all done. They're all like installed like this kitchen one, so it looks pretty cool right now. Is that it? Wow, I was expecting like to be grilled, you know, like.
What were you thinking?
Yeah, that's Jesse's question. That's
So are you saving this for Max? Because he's gonna take it over, right?
yeah, that's true. The next owner of this.
Documenting it all?
Yeah, no, of course, yeah. There's a wiki, like it's all yeah.
Here's the camera in your house.
Yeah, exactly. We'll put it. Yeah, Jesse's like I see, you know, Jesse and I work together, and he's always like, "You're crazy. What are you doing? Like you are completely crazy."
Are you running like Romex into the walls just in case you ever like want to sell it?
Yes, that's a good question. Yeah, so we did that. So all the light switches that have just Cat6, we also ran Romex to that switch. So then we could put in a wireless smart switch. It would still have to be a smart, because that switch is not hooked up to any lights, you know. So it would still have to be like a smart switch, but it could be like a, you know, a commercial smart switch, not my smart switch, that would run off of the line voltage, and then it would wirelessly like switch these things on and off. So like that's our backup plan. If this system doesn't work, or if we sell the house, you know, we could do that.
Very cool, man.
Okay, that's it. Yeah, house tour. So we can just go around.